Okay, so now we're going to talk about the case when the population standard deviations are thought to be the same. So we can find ourselves in the situation where we want to compare two groups. More specifically, we'll be interested in comparing the population means for these two groups, assuming what's called independent samples, as well as assuming that the population standard deviations are equal. So when we're in the situation when we want to compare the population means of two different populations, and when we can assume that the population standard deviations are equal, we follow these 5 steps for conducting a test of hypotheses. So step 1, we state our null and our alternative hypotheses. Step 2, we set the significance level. Step 3, we determine the appropriate statistical test. Step 4, we then determine our p-value and compare it to our significance level. And then step 5, we reject or fail to reject the null hypothesis, and then we interpret our results. So let's run through an example using the Prison Climate Survey. So in the Prison Climate Survey, we might be interested in comparing 2 different prison facilities after some riots had happened. So we have 2 different facilities. One is Belwatt, and the other one is Franklin. And we might be interested in knowing about whether or not these 2 facilities differ in terms of their average level of livable environment rating. So what we can do is we can go out and we can take a random sample from Belwatt of, say, inmates and staff. We can then go out to Franklin and take another random sample. So in this case, we took a random sample of 74 and a random sample of 70. From that sample data, we can then calculate sample means and sample standard deviations for the samples we drew from each of those facilities. Now, as part of this prison climate survey, one of the questions I was interested in was, after the riots, was there a statistically significant difference in livable environment between these 2 facilities? So here I am, this researcher. I've collected all this data, and I think there might be a difference in livable environment between the 2 facilities. However, I'm not exactly sure of what kind of difference I'm going to see. I don't know which one is going to be greater or less than the other one. I just have this suspicion that the 2 facilities will be different. So formally, I can take step 1, where I state the null and alternative hypotheses. So in the context of the Prison Climate Survey, my null hypothesis is that there is no difference in environment livability between Belwatt and Franklin. So their population averages for environment livability are the same. My alternative hypothesis could be that livable environment at Belwatt is different from Franklin. So each of these populations has some average environment livability, and I might think that they are not equal to each other. So when thinking about the null and alternative hypothesis, especially when we're talking about comparing 2 groups, I often think about the null hypothesis as being your traditional doubting scientist hypothesis. So the doubting scientist is the scientist who is always skeptical, who always believes that nothing works, that things are never different. So when trying to figure out whether or not these 2 population averages are different, I, 1, give that doubting scientist the benefit of the doubt. And I say, okay, your hypothesis was that there is no difference in environment livability between Belwatt and Franklin. Population average livabilities are, as you say, no different from each other. They are the same. In addition to this hypothesis, I might have my own hypothesis. So as a researcher who has been studying prisons for years, who has been involved in these facilities, who's talked to people, my suspicion might be that the average environment livability between these two facilities is different. Now, I may have done a fair bit of research, but that prior research might not have been super conclusive. So in this case, I might be kind of conservative and say, while I think that these two facilities are going to differ, that I'm not exactly sure how they're going to differ. So one might be larger than the other, but I don't have enough prior experience to say which one is going to be greater than the other one. Now, I also want to point out that this alternative hypothesis that I came up with is just one of 3 possible alternative hypotheses that you can come up with. So the first alternative hypothesis, as we talked about last time, is a two-tailed test. So this is the hypothesis that claims that the population average for the first population is simply different from the population average in the second population. Yes?
So for the two-tailed test, should we use that as an alternative hypothesis if you don't know if it's going to be greater or less than the population? So like basically you use it to kind of cover all bases.
Exactly, right. So if you're not really sure how the averages are going to differ between these two populations, you can just default to a two-tailed test. This test is considered to be fairly conservative, so it's a lot harder to reach this two-tailed conclusion. But if you do find yourself in that situation where you simply do not know, then it's something you can rely on. Now, if let's say I had more information about these facilities and I felt very strongly about something, I might be able to make a claim that the population environment livability average is in fact greater at one of these facilities than the other one. So if I thought that the population average was greater at Bellwatt than Franklin, I'd be conducting an upper tail test. And what that effectively means is that I'm making the claim that the population mean in the first population is greater than the population mean in the second population. Now, alternatively, I can make the claim that the population mean in the first population is in fact less than the population mean in the second population. So if I did that, then I'd be doing what is referred to as a lower tail test. So in the context of the prison climate survey, I didn't feel like I had enough information to conduct an upper or a lower tail test. I thought they were different, so I decided to play it safe. I decided to play it conservative and conduct a two-tail test. However, when it came to this choice of which alternative hypothesis I wanted to test, that was my choice based off of my background information. So I get to choose between these 3 different outcomes, 3 different alternatives to the idea that the population averages are the same. In step 2, we set our significance level. So recall, one interpretation of the significance level is that your significance level is essentially the amount of risk that you're willing to take when it comes to rejecting, say, a true null hypothesis. So we have this null hypothesis, and we're trying to decide about whether or not we should reject it or fail to reject it. Now, by making this decision, we recognize that there's a chance that we can be wrong. And here's the rub. There's always going to be a chance that we're going to make the wrong decision. And that can never go away. However, we can decide about how much risk we're willing to accept when making that decision. So when we set our alpha level, that's what we're doing, is we're saying how much risk we're willing to take. Now, the scientific convention is to set our alpha level to 0.05. So what this basically means is that when we make our choice about whether to reject or accept the null hypothesis, that there's a 1 in 20 shot that we're going to be wrong, and that we're okay with that. So step 3, we then determine the appropriate statistical test. So in this situation, we're conducting a difference between two population means test, assuming that the samples are independent and that the population standard deviations are equal to each other. So 1, we know we're conducting this test because what we're doing is we're looking at the differences between two population means. 2, we know that the samples are independent because the responses from the first population do not influence the responses in the second population. And for 3, we know that the population standard deviations are equal based off of our understanding of the variation in the two populations. So in the case of the Prison Climate Survey, I've got two populations, Bellwatt and Franklin. These populations both consist of inmates and staff who spend a lot of their time at either a combination of a medium/maximum facility. So when I think deeply about what I know about these two populations, I am not able to find any reasonable reason to consider the variation in their